There's an interesting relationship hidden in C and C++, and that's the relationship between arrays and pointers. And it's important to understand this relationship because once you do, you will understand both arrays and pointers a little bit better. Now, before you watch this video, I'm going to assume you've watched my previous video on understanding pointers because the concepts in that video will really help you here. Just as a quick recap, we talked about how when you declare and initialize a variable in C++, what you're really doing is creating an entry in a symbol table, and that entry has a type, a name, and a value stored at an address. And when we set the value, we look up the name in the symbol table, and then we change its corresponding value. When we use the value, the same thing happens. We find the name in the symbol table, and we get the corresponding value. Every time we create a new variable, the same process happens. A new entry is made in the symbol table at a specific address with a type, a name, and a value assigned. So again, if that doesn't sound familiar, go back and watch my video on understanding pointers in C++. Now let's talk about arrays. You've probably seen an array declaration that looks a little bit like this. One way to think about this, in terms of the symbol table, is that an entry is made in the symbol table for each item in the array. And like all symbol table entries we've discussed so far, those entries have an address, a type, a name, and a value associated with them. So for example, we've created an array called numbers with 5 integers, and we've set those integer values to be 10, 20, 30, 40, and 50. And we now want to print out the item located at index 0. And it's pretty easy for us to predict what's going to happen here. Item at index 0 is the value 10, and so we print out the value 10. But what happens if we print out the numbers array itself? What would we expect to print out? All 5 numbers, perhaps? Instead, we get a cryptic memory value. And if you're unfamiliar with the relationship between arrays and pointers, that might be confusing. Why this particular memory value? If we look at our symbol table, we can see that the memory value printed out is the same as the first item in the array. But why is that? So just like I mentioned in the previous video about pointers, whenever things start to not make sense in C++, there's a good chance that we're using the wrong abstraction. And while it's correct that we're using a symbol table to store the values of this array, the symbol table for an array does not look quite like the one we've constructed here. So let's go back to our array declaration. When we create a variable with square brackets, it means to reserve a block of memory. Now in this case, we are saying that that block of memory should be large enough to hold 5 ints. And so the program will allocate that much memory for us, reserving a spot in memory to hold 5 integers. Now assuming our computer uses 4 bytes to hold each integer, as many computers do, each of those spots or chunks of memory will be exactly 4 bytes large. So there'll be 4 bytes of space between the addresses of each one. Now, the next thing we're going to do is we're going to store some values in that memory block, the values we've specified here in the curly braces. So those values get stored in the place that we've reserved for them. Now so far, everything about the way we've constructed the symbol table looks similar to what we said before. But the key difference is the final step. The final step is to store a pointer to our memory block in this variable. So we've reserved a block of memory large enough to hold 5 integers, and we're going to store a pointer to the beginning of that block in the variable numbers. And so in order to do that, we need to create an entry in our symbol table for that pointer. The pointer is going to be an int pointer. It's going to be named numbers, and its value is going to be the address of the beginning of the space we reserved for our 5 ints. Now notice that the block of memory for the array does not itself contain any names. There are no names associated with the block of memory. The only name we have is the name for the pointer to the block of memory, and that is the key to remember. So with this new entry in our symbol table, we can now understand better what's happening when we print out the variable numbers, because the value for the variable numbers is the address of the chunk of memory we reserve for our array. Now what about this line? If we prefix the name of the array with a star, remember from our previous video that the star in front of a variable means thing pointed at by. So in other words, this expression says print out the thing pointed at by the variable numbers. Well, the variable numbers has a value of this address. It's pointing to this row in our symbol table, and the value associated with that row is the value 10. And so if we were to print out star numbers, we would get the value 10. Understanding the fact that what we're actually storing in this variable is a pointer helps us to make sense of both of these lines. Now, you might be asking yourself, okay, that makes sense. But what about this line? If you said that these names don't exist in the symbol table, how does it know to print out 10 in this case? To understand that, we need to go a little bit deeper. Now, again, our mental model up to this point has been that there's a name in the symbols table for numbers bracket 11, and that will allow us to find the value 20 and print it out. But as we said, there are no names associated with these brackets. The only name in our symbols table is the name of the array itself, storing a pointer to the beginning of the block. So to understand how this works, we need to look at what happens when we print out numbers plus 1. As we said, the numbers variable stores an address, specifically the address associated with the beginning of our array. So now we're sitting here looking at this address, and we have a plus 1. The plus 1 doesn't mean add the number 1, it means to add one more chunk of memory. So since our chunks of memory are big enough to hold an int in this example, 4 bytes long, we're going to add 4 bytes to our address, and that puts us here in the second entry of our symbol table. So when we print that out, we get the address of the second entry of our symbol table. Now, if we want to see the value associated with that, we can wrap the whole expression in a star. Because remember, the star says the thing pointed at by. So in this case, it means the thing pointed at by one memory chunk after numbers. And so to understand this expression, first we find the value for numbers, which corresponds to this address. We move forward by one chunk of memory, and then we find the thing that that chunk of memory is pointing at, which in this case is the value 20. And so this explains how the brackets work. The expression numbers bracket 1 is the same as thing pointed at numbers plus 1. Those two statements are equivalent. They both mean the thing pointed at by one memory chunk after numbers. So you might mentally think we are looking for a name called numbers bracket 1 and getting its value. But what's actually happening in both cases, we're finding the value for numbers in our symbol table, which corresponds to an address in memory. And then we add one chunk of memory to that, find that location, and then get the thing pointed at by that memory. So this process is how we find the numbers for the first entry in the symbol table, and the same concept applies for every item in the array. The only thing that's different is the number indicating how many chunks of memory we move forward from the beginning of the array. And so now you know the relationship between arrays and pointers. Hopefully it helps you to understand both a little bit better.